Hello everyone, welcome to the channel, and today I will show you how to perform a supervised image classification using Sentinel 2A image in Google Earth Engine. So let's get started. So to perform a supervised image classification using Sentinel 2A image, we have to define our study area. So that is ROI, that is our region of interest. So now let us define our study area. So define a study area, let me select this particular study area. So I'm selecting the study area as Chennai. So to define your study area, I'm going to use this particular, that is add a marker, that is a place marker. Click this. Now place your marker in your study area. So now I have placed a marker on my study area. So that is indicated. So that is indicated in this section, variable called geometry. So now let me rename this geometry name to ROI, that is region of interest. So now let me rename as ROI. So now we can also choose your color. So color code also indicated here. So you can choose your desired color. Let me click OK. So now let me load the Sentinel 2A image into Earth Engine. So to load our Sentinel 2A image into Earth Engine, we have to define a variable called image equals to image collection Copernicus S2 SR. So this is a code which is used to import our Sentinel image into Earth Engine. So next we have to filter with a specific time, that is dot filter date 2020 January 1 to 2020 December 31st. So to perform a cloud filter, so we have to define. So to get a satellite image with the least cloud contamination, we are using this particular function, that is dot filter dot lt cloud pixel percentage, that is lower than 20 percentage. So now we are filtering with our study region, that is our study region. So that is ROI, region of interest. So dot median function. So here we are using a median function in order to acquire a single image from this large time series. So that is from January to December. We will acquire a single Sentinel image out of this timeline. So for that we are using a median function. So next we have to set a visualization parameter for our Sentinel-2A image. To set a visualization parameter for the image, we define a variable called visParam_true, that is visualization parameter true color composite equals to bands. So the bands, we will use band 4, band 3 and band 2 with the minimum value of 0 and to a maximum value of 2500. So now let me show you the details of Sentinel-2A bands. So this is a Sentinel-2A bands. So this is a Sentinel-2A bands. We have around 12 different bands for this Sentinel-2A image. So with band 2, band 3 and band 4 is of 10 meter resolution. So that is blue, green and red. And we have our band 8 is of 10 meter resolution, that is visible and near infrared band. So there is a total of around 12 bands in Sentinel-2A image with 4 bands of 10 meter resolution. So now let me get back to our Earth Engine code. So now to define our visualization parameter, we defined a variable visParam_true bands B4, B3 and B2. So here B4, B3 represents B4, B3 and B2 represents red, green and blue. It is of 10 meter in resolution. So minimum is set to 0 and maximum set to 2500. Now gamma is set around 1.1. And to add this layer into Earth Engine, we have defined map.addLayer. Image here represents our Sentinel-2A image. And to set our visualization parameter, we defined visParam_true here. So it represents this particular variable. So output the layer name as Sentinel 2017. So now let me replace this. So output the layer name as Sentinel 2020. And to center this layer, we have to define map.centerObject ROI. Here represents our study region, that is indicated here. So this is our ROI study region and with a zoom level of 8. So now let us visualize our Sentinel-2A image. So go to the option called Run Script and click Run Script. So this is our Sentinel-2A image that has been added into our Earth Engine. So now let us visualize the different features that is available in this image. So in this section, we can able to see there is a lake. This particular lake is called as Pulicat Lake. And let me show you other features. There is several water bodies have been located in the study region. So the image is in true color composite. So let us with the 30-meter resolution. So there is a 10-meter resolution bounce. So we can see this is a canal system, and there is a river, and there is another river. So we can see several features have been available in this image. We can clearly visualize the different urban settlements, urban areas, and also the vegetation. And even the beach is also visible here. So now to perform a supervised image classification, we need to provide a training data to our supervised classification model in order to perform the supervised classification image using Sentinel image. So for that, we have to provide some training data to our. So to perform our supervised image classification, we have to provide training data to our supervised classification model. So now let us create a training data for that. So go to the option called geometry imports. Now click this option called new layer. Now go to this option called edit layer properties. Now enter the name as water. So now I have entered the name as water. Now select, let me choose this option called feature collections and click this property and enter as class. Now enter the value as 0. So now click also you can choose your color. Now let me choose a color for our water bodies. So this is the color. Now click OK. So now let's start provide a sample data, that is provide a training data to a model. For that, let me click this water bodies. So let me select this rivers. So let me provide some sample data for water bodies. So that is, it is a lake. So let me select in these areas too. So we have to provide a sample training sample for overall water bodies that is present in our study region. So let me click this. So these are the lakes. So you can also confirm whether it is a lake or not. You can just go to the option layers, turn this off, and click the satellite mode. So now you can clearly able to visualize it is a polar lake. And so this is an Ambattur lake. Now let me turn this layer on. Let me take some samples of this water bodies. So this is an Adaya river. So it is meanders through our study region. Let me take some samples. So this is a canal route. So this is a canal. The name of this canal is Buckingham Canal. So now we have around 84 points for our water bodies. So now let us create another layer. Go to the option called layers. So now go to the option called edit layer properties. Now let me rename as a build up. So indicates our urban area. So let me rename as build up. So now let me select the import as a feature collection. So use the properties, go to the properties and select enter a class. Now enter the value as 1. So now click OK. So it is now clearly indicated in the bold color. Now we are ready to take samples. Suppose you want to turn this off, you can click this. To turn this on, you can click this. So now let me take the samples of our urban area, that is a build-up region. So let me here change the color for the build-up. Go to this option, edit layer properties, and choose your color. So let me choose a red color for build-up. Now click OK. So now let me take few more samples of build-up areas. So now I have taken around 121 points for our build-up areas. So now let me add another layer. So now let me add another training data, that is vegetation. So I have created a new layer. Go to the edit layer properties. So let me rename as vegetation. So now let me import the type as feature collection and go to this, click this property option. Now select class. There is enter class value, enter as value 2. Now let me select the color. So let me choose this color. So I've selected a green color for vegetation. Now let me click OK. So now that is clearly indicated in the bold color. Now let me take some training sample from vegetation areas. So I'm taking as training data from all vegetation features in the study area. So vegetation areas are clearly indicated in green color. So now let me take this is a national park. So now I have selected a vegetation sample training data for around 73 points. So now let me add another layer, that is barren. Go to the option called edit layer properties. Now enter the name as barren. So import as feature collection and select this property, enter class. So enter the value as 3. So now choose your color. So for barren, let me select the color as yellow. So now click OK. So now let me provide a sample training data for our barren features. So let me select a barren land. So now let me take the samples from this area, training samples. So we can also confirm with our base map. So this is our base map. So now let me select these areas. So now I have selected a barren training samples for barren lands in our study region. So now let me add another layer. So go to the option called geometry input. Now click a new layer. So now go to the option called edit layer properties. Enter the name as roads and the import as feature collection and click the properties and enter class and enter the value as 4. Let me select a color. So now click OK. So now let us select road features in our study region. So this is the road. Now let me take the samples of the road. So this is the road network. Let me select. Let me select this areas too. It is also road. So you can also verify with your base map. So this is the road. So selected around 56 points. So now we have created around 5 different features from our study region. That is, we have created 5 different training samples from our study region to provide it to our supervised classification model. So now let me show you the different features. So that is indicated here. We have water, build-up, vegetation, barren, and road training data. So now next we're going to perform is we're going to input this training data into our supervised classification model. So for that we need to create a training. That is, we need to import this training data into our supervised classification model. So now, before that, we have to merge each of these different elements together. That is, we have to merge all these water features together and all the build-up features together and also the road elements together. So in order to import this data into our model. So now, so before we import our training data into our model, first we have to merge this training data. So we have to merge the water, build-up, vegetation, barren, and road together. So all the elements together for water and all the 121 we have to merge the element in build-up. So for that we define create a training data. For that we defined a variable called training. So this specific code will merge all our training data together. That is, it will merge water, build-up, vegetation, and barren land. So to import our training data, first let us merge our training data together. So these are the training data: water, build-up, vegetation, barren, and roads. So to merge this, we created a variable called training equals to water dot merge, build-up dot merge, vegetation dot merge, and barren dot merge. So to view this data, so we have defined print training. So now let us view this. Let me remove this. So now go to the option called run script and click run script. So now let us view the merged training data together in the console section. So it is visible in the console section. So we have features of around 369 elements. So that is you can add this all these elements together. We get around 361 elements. Let us view this features. So right from starting from 0, we have up to a lot of features up to 369 elements. So let us view this. So this feature indicates class 0. So class 0, it is water. Class 1 is build up, and class 2 is vegetation. Class 3 is barren, and class 4 is road. And similarly, let me show you other features. So this feature indicates so it is a class 1. So class 1 feature indicates that is build up areas. And similarly, so 259 so indicates a class 2 feature. So class 2 feature is 0, 1, 2, that is vegetation. So it provides a lot of information related to our features. So now let us create a parameter that will be used to import our training data into a supervised classification model. So for that we defined a variable called label equals to class. So class here refers to our training data sets. So in the training data set we are defined as a class during our training creating a training data. So for that we referred as a class. So now what are the bands we're going to use to perform this classification? So for that we're going to find a variable called bands. So we're going to use band 2, band 3, and band 4 and band 8. So band 2, 3, and 4 are red, blue, and green, and band 8 is of near infrared. So all the four bands of 10-meter resolution. So now to input this image into so select this bands, we have to define variable called input equals to image. So image refers to our Sentinel image. So this is here, so indicate it here. This is a Sentinel image. Image dot select bands. So bands here refers to this variable. So selects the band 2, 3, 4, and 8. So next we have to train our model. So in order to train our model, we have to overlay the points on the imagery. That is our training points on that imagery to train our model. So for that we defined a variable called train image equals to input dot sample region and collection referring to training and properties, that is of label, and scale is of 10-meter resolution. So properties here, label refers to this variable. So what we're doing is in this function, in this particular function we are doing is we're extracting a Sentinel bands from using our training data. So next what you're doing is we are from the training data, we are using 80% of the data to perform our supervised classification, and the next 20% of our data we are using for validation of our to check for the validation of our classified image. So the 80% of the data will be used for classification and the 20% of the data will be used for validation. So for that we could define a variable called training data equals to train image. So the train image here refers to this variable. So dot random column. So it will generate random points where the 80% of the data will be used for our classification purposes and remaining 20% of the data will be used for validation to check for the accuracy. So now we define a variable called training data equals to train image dot random column function and defined a variable called train set. So train set equals to training data dot filter dot filter less than, that is random points with 80%. So it shows that the 80% of the data will be used for our supervised classification. And similarly, the variable we have defined a variable called test set. In this, the 20% of the variable will be used for validation to test for the accuracy of our supervised classification image. So for that, we defined a variable called test set equals to training data dot filter dot filter dot greater than or equals to random 0.8. So it will be greater than 80 refers to 20% of the data will be used for validation. So now to perform our supervised image classification, so we need to input our training data into our models. So for that we defined a variable called classifier equals to classifier dot smile cart. So cart here refers to classified regression tree technique. So tree method that is used for classification of our image. The dot train refers to train set. So train set here refers to this variable, that is our 80% of the data will be used for classification, and label here refers to this variable. So this specific variable where we have mentioned the bands, and the bands here refers to this variable. So we are using band 2, 3, 4, and band 8. So next we have to classify the image. So to classify the image, we defined a variable called classified equals to input dot classifier. So classifier as a variable here. So we are importing our model into this model into for classification. So we are using this referring to this variable. So this variable is it is our classification model. So to get the details about this image, we are just mentioning print classify.getInfo function. So next, to find our color palette for our classification, we defined a variable called landcover palette, and this specific number will represent our this particular feature. That is, the blue represents water, and build-up represents red color. And similarly, for barren, it is represented in this color. So to add the supervised classified image into our Earth engine, we have defined map.addLayer classified. So classified here refers to our classifier. So this variable. So this variable classify our image into a supervised classification based on our training samples. And for the palette here refers to our landcover palette. There is a visualization parameter. This represents this variable, and we set a minimum value of 1 and to a maximum value of 6, and output the layer name as classification. Now to check for the accuracy of our supervised classified image, we have to perform an accuracy assessment. So to perform this accuracy assessment, we have to so we are going to use our test set variable. So previously I have said that we are using two different variables. One is train set, in which 80% of the variable will be used for classification, and test set, the 20% of the variable will be used for validation. So here we're using the particular variable test set and to generate a confusion matrix. So to generate a confusion matrix, we defined a variable called confusion matrix equals to doubly dot confusion matrix test set dot classifier. So classifier here refers to, so the classifier here refers to our model. Let me show you that. So this is a variable classifier refers to our cart model, that is classification and regression tree. So dot error matrix. So actual class represents our training samples and predicted represents our classified image. So it compares both actual and predicted classes, the actual and predicted, in order to identify the accuracy of our image. So to view our confusion matrix, all we have to do is define a print confusion matrix and the layer name confusion matrix. And next, to see the overall accuracy of our supervised classified image, we have to to view that, we have to define print overall accuracy and confusion matrix dot accuracy function. So in this way you can check for your accuracy of your classified image from the training sample. So now at last we have to export our classified image to our Google Drive. So for that we define export.image to our drive. So image here represents, so the image here represents classified. So to export our classified image to a Google Drive, we have to define export.image to drive. Image here represents classified. So classified here refers to our final image, that is this one, variable called classified. And the description is the Sentinel to a classified cart. And scale is around 10 meter resolution. Let me change this. So scale is around 10 meter resolution, and region is ROI. The study region is represented ROI, region of interest, and maximum pixel is represented in this value. So now let us run this code. Go to the option called run script, click run script. Now let us view our accuracy of our classified image and the confusion matrix. So now you can clearly, we have, this is our confusion matrix. So this is our confusion matrix, and this is the overall accuracy of our classified supervised classified image, that is 98.41%. So this is our overall accuracy of our classified image. Now let us view our classified image. So let us view our classified image. So this is our classified image. You can clearly able to view here. So the water bodies are here indicated in blue color, and the settlements are here indicated in the red color, and the variant here indicated in this, that is in this color. So here you can clearly able to view here the water bodies are indicated in this water, that is in blue color, and the settlements and the road networks are here indicated in the green color. So you can also change the color of this composition. So right here, right in this classified image, the color is kind of different because water body is represented in blue color, and the road networks and the settlements are here represented in green color. And let me show you that. So here the water bodies and settlements are here. Let me zoom. So this part of this been indicated in, so that is indicated in green color, and the barren lands are here indicated in red color, and the vegetations are here represented in. So you can now clearly able to view here. So the water body is indicated in blue, and the vegetation is indicated in this color, and the barren lands are the water body is indicated in this color. And let me see this, what does this color represents. So this particular color represents barren. So let me turn this on. So this color is as a barren color. Now let us view the settlements. These are the different settlement areas. So settlements are indicated in this color, that is in green color. So these are the settlements. The roads in this color is represented. Roads and the build-up areas are represented in this light green color, and vegetations are represented in red color. So you can clearly able to view. You can almost classify all the. We can see all different types of features in the study area. So you can also change the color of this. So you can go to this option and change the color according to your wish. Suppose if you want to change this color to a black, so go to this option called geometry imports, go to the edit properties. So you can see this number, yeah. So you can also change the color composite. So let me down, suppose you want to choose a black color, just copy it and paste it in this section. So paste it in this section, you can change the color of this features. So last we have to export our to download the supervised classified image to our Google Drive. So for that, so go to the task section. So here there is a task section is available. So here, so unsubmitted task. So to export your classified Sentinel image to your Google Drive, all you have to do is click run. So to export this, so it is a 10-meter resolution and EPSG coordinate system, and it will be exported to our drive, file name and GeoTIFF file format. So to export this image to your Google Drive, all you have to do is click run. So in this video, I have shown you how to perform a supervised image classification using a Sentinel-2A image. And I have shown you how to load a Sentinel image, set a visualization parameter, and how to create a training data, and how to classify our image and set a default visualization parameter and assess the accuracy of our classified image, and finally to export our supervised classified image to our Google Drive. So thanks for watching. Please subscribe to our channel and give us a like. So now you can clearly able to view here. So our Sentinel-2A image has been uploaded to our Google Drive. So you can open your Sentinel images by open your drive and download your supervised classified image. Thanks for watching and subscribe to our channel.